really nobody fundamentally at a certain level understands quantum mechanics, but it's the most successful theory that we have.
What makes you say that?
Oh, because it has many practical applications. Your smartphone stores data in flash memory. Flash memory only works because of quantum mechanical tunneling, which is one of the most incredible effects in all of science. It really says that if you kick a soccer ball against a wall, there's a finite chance this ball will make it through the wall. If you do this experiment with a soccer ball, it has a far too small probability to happen. Now, if you go to very small entities, to electrons or protons, electrons need to be put or subtracted from certain small regions in flash memory to store the information. That's only happening because of quantum tunneling. Sometimes people say to me, oh, this is a nice theory. We don't believe it. And I say, if you don't believe quantum mechanics, you should not be using your smartphone. Because if you don't,
you don't believe it.
Exactly.
I mean, it's a mesmerizing experience to look at the stars, I think. I think I can say this for everybody, is that they somehow, lose themselves when looking up into a starry night sky and realize how big the universe is, right? And then you kind of look at your feet, and for a second, you realize how small you are compared to this huge, vast universe. So I feel that looking up the stars makes you place yourself in the cosmos, understanding that this is an expansive world that we don't know about. Do you get inspiration from looking at the stars? Did some of it influence you to become an astrophysicist?
Oh yeah, I think this is true for all of us, and each of us, we see or we feel something slightly different when we look at the stars. You mentioned that you get a feeling for how big things are. But really, if you just look at the night sky without telescopes, I don't think you really can get a feeling for how big the universe really is. Because to the ancients, they thought there is this sphere far away, but it has little holes. And those are the stars, meaning the sphere is at a fixed distance. Already, just by looking at the stars, you know that there's something out there that's vast, but you cannot imagine how vast it is. We have no intuitive feeling for that.
Yes.
So
Right.
for me, of course, it's a spiritual experience. If you are at a very dark sky location and you can see the Milky Way, and what is interesting to me is that the stars at fixed positions, so apart from the planets, the stars, the entire sky rotates because of the rotation of Earth. So there's something very regular there. And it happens every night. And this regularity that you have no impact on, you cannot reach out and touch the stars, and you cannot make a star move differently. This regularity is in complete contrast to the very chaotic life on Earth that is so different, that's changing all the time, our interactions with our friends and peers and what humans do.
Yeah, to me it's almost like a manifest that there's like two different time scales, or there are many different time scales. We have the time scale of the cosmos where, if we look at how much time we've actually been part of the history of the cosmos and we put it into like a 2-week period, I think it's like something around humanity only lasts like 2 seconds of the last day. So there's something to be said about our sun is dying, right? Technically, like it's a star that is dying, but because we don't belong in that time scale, we perceive it differently.
Yeah, no, you're right. And the sun, it will evolve like every star, but it's in middle age. So it's about 4.5 billion years old, but it will go another 5 billion years.
Right. We don't have to worry about it.
Yeah, no, we don't have to worry about. This is another thing that we have intuitive problems with. Exactly what you just said. Human life, those few million years on a cosmic scale, that's really nothing. That's a blink of the eye. So not only do we have these vast distances for which we have no intuitive feeling for, but also we have these huge time duration.
That's kind of what Einstein's theory of relativity starts to compare and answer, right?
Yes, correct. Yeah, this is our best theory, the theory of general relativity, our best theory for vast scales in the universe. It's one of the pillars of our fundamental understanding of nature. People are always interested in, well, what is space and what is time? Philosophers centuries ago, they thought about is, can there be space without time? Can there be time without space? Which one is more important? So the theory of general relativity, which Einstein published in 1916, tells us that there is no separate space and there's no separate time. There's space-time. And space-time is very different, behaves very different from our everyday experience. We don't need to worry too much about space-time in everyday life, but when you go to larger scales, it becomes important. So the theory says that whenever you have a lot of mass somewhere in the universe, then this mass will warp the space-time. And once you realize that, then a lot of different phenomena are possible that are absolutely mind-boggling. For example, black holes or wormholes and many other things. And this was the big revolution in our understanding of how the space-time really is very different to what we perceive in everyday life when we think about space and time separately.
I have a hard time trying to like put a word onto what would you describe is space-time. So is it an entity? Is it a force? Is it a fabric? What would you what would you say it is?
So nobody can really imagine it in a simple picture or an image
Like as a
because
human.
it's a four-dimensional construct, and
Mm,
we only can think in spatial and three spatial dimensions.
that's interesting.
And when you do see sometimes when it's explained to students that space-time is like the surface of a sphere, or depending on the curvature, it's like a saddle shape. But these are just very crude images. These are analogies. This is not the real thing. When you say it's a fabric of some kind. When we say space-time expands, then people sometimes think that there's something moving within, and it's not moving within. It's really space-time itself that changes. You cannot imagine it in a simple. It's very similar to quantum mechanics, which you mentioned earlier. We have analogies, but all the physics in quantum mechanics is embedded in the wave function. We cannot imagine simply a wave function. And textbooks will have these little waves, but the wave function is complex. It's a complex entity. It's not a real thing, but it has all the physics embedded in it. And once you understand this wave function, you can manipulate it mathematically, and gives you all the effects that happen in reality.
You mean a wave function meaning like a sine wave?
A sine wave, but that's just a crude sketch. So a wave function is not simply a sine wave, and it's not a real wave. So when you go back to the history of quantum mechanics, early on, people thought maybe it's a real wave, a meta wave, but it's not. It's a mathematical construct that tells you if you square this expression for the wave function, that tells you something about the likelihood of finding an object at a given point in space. So when we talk about radio waves, then these are physical waves, and we know what the wavelengths are. And yeah, we cannot see them, but we know they're a real entity. We can think about them, but not so a wave function. And this is the reason why it took people such a long time to wrap their heads around this. And really, nobody fundamentally at a certain level understands quantum mechanics, but it's the most successful theory that we have in all of science.
What makes you say that?
Oh, because it has many practical applications, and quantum mechanics, of course, explains all natural phenomena. I should say there's no phenomenon that contradicts quantum mechanics. And if you think about all these objects, for example, when you're using your smartphone stores data in flash memory. Flash memory only works because of quantum mechanical tunneling, which is one of the most incredible effects in all of science. It really says that if you kick a soccer ball against the wall, there's a finite chance this ball will make it through the wall without breaking the wall. It will not go over the wall. It will go through the wall without breaking it. And if you do this experiment with a soccer ball, it has a far too small probability to happen, even over the lifetime of the universe. But the probability is not zero. Now, if you go to very small entities, to electrons or protons, this does happen. And it's very important. We talked about nuclear astrophysics. Fusion reactions in stars, they only occur because of quantum tunneling. And back to the information is stored in flash memory. So electrons need to be put or subtracted from certain small regions in flash memory to store the information. That's only happening because of quantum tunneling. So sometimes people say to me, oh, this is a nice theory. We don't believe it. And I say, if you don't believe quantum mechanics, you should not be using your smartphone. Because if you don't,
you don't believe in it.
Exactly.